Okay, in this question, we need to determine the number of points of intersection of the following pair of graphs. So here we are given the equations of the two graphs. The first graph is y equals to 3x squared minus x plus 5, and the second graph is y equals to 5x plus 3. Okay, this type of question looks similar to a type of question we came across earlier. Let's take a look at that type of question. So here is, we are given the equations of two graphs, and in the previous question, the type is we have to find the coordinates of the points of intersection between the two graphs. So for such question, we're essentially finding the solutions of these simultaneous equations, this pair of equations over here. So what we'll do at the start is always to name the equations 1 and 2, and then we do the substitution. Remember that we always substitute the linear equation to the non-linear equation. So in this case, is substitute equation 2 into equation 1. So we do our substitution. Okay, and then we simplify the equation. So I'll just quickly show the steps over here. Okay, after simplifying, we will get x squared minus 4x plus 3. So essentially what we have done is we substitute a linear equation to a non-linear equation, and we simplify it to obtain the quadratic equation. And from this quadratic equation, we solve it first by factorizing the left-hand side, and then proceed to solve for x. So finally, we need to find the corresponding value of y for x equals to 1, and the corresponding value of y for x equals to 3. So we do our substitution again. So we substitute x equals to 1 into the equation number 2. And we get y equals to negative 3. Same thing for x equals to 3, we substitute into equation 2. We get y equals to 1. And then from here we conclude that the coordinates of the points of intersection between the two graphs are 1, negative 3, and 3, negative 1. 3, 1, sorry. So now let's go back to the new question we have here. So the problem solving steps are actually similar for both questions to some extent. So the way we approach this new question is again to solve the two equations simultaneously. So we label the equations 1 and 2. Then we substitute the linear equation to the non-linear equation like this. So we do a substitution. And then we simplify the equation like before, so that the left hand is a quadratic equation where the left hand side has all the terms and the right hand side is 0. So we'll pause a while over here to discuss some pointers. Let's compare the working so far for both questions. So in both questions, we start off with substituting the linear equation to a non-linear equation to obtain a quadratic equation. And in the previous question, we went on to solve the resulting quadratic equation. That is because we have to find the values of x and y, which are solutions of these two, because we have to find the coordinates of the points of intersection. But in this new question over here, we realize that we just have to determine the number of points of intersection. So we don't actually have to find the exact value of x and y like in the previous question. So this is the juncture where the two workings will differ. Because to determine the number of solutions to this equation, we just have to calculate the value of the discriminant, b squared minus 4ac. This is enough for us to determine how many solutions are there to this equation. So we calculate this, b squared minus 4ac. Here, the discriminant is 12, which is greater than 0. So from this observation, we can say that there are two distinct equations to the equation 3x squared minus 6x plus 2 equals to 0, essentially, which is this. And if there are two solutions to this, it means that there are two solutions to this pair of simultaneous equations. Two solutions means that we will have x equals to something or x equals to something else. So here we can actually conclude something really, because we can say that the graphs intersect at 2 points, because like here we know that there are two solutions. We don't actually care what are the two solutions, we just need to know that there are two solutions, and hence the graphs intersect at 2 points. And then we are done.